Estonia talks a lot about e-health, and this has been a topic that I think has just come up even in this last panel. The panelists said, where will the next major innovations come from? From the juncture of health, big data, artificial intelligence. Well, if I were to start writing our keynote speaker's description, I think that pretty much would be it right there. Expertise in big data, health, and artificial intelligence coming to us from IBM Watson and Nicky Hekster. Thanks.
Okay, thank you. Okay, hi everybody. Thank you for joining me here. It's pretty empty in comparison to the previous speaker, but it doesn't matter. You're really interested in this topic, I hope. So my topic is transforming healthcare through artificial intelligence. And in the coming 15 minutes, I will show you what's happening, what are we doing as IBM, and how you can engage as a startup or as a company or a government with us. Okay, so this is me. My name is Nicky Hekster. I'm already working for ages with IBM. I won't mention the number of years, but I'm a technical pre-sales with Watson Health, which means that I'm supporting teams in different countries across Europe with our products. And you see a DR in front of my name. I'm not a doctor, but I'm a mathematician. And this was also why I became interested into artificial intelligence, because there's something here. It's cool these days, but it's very, very old artificial intelligence. As a matter of fact, it started already with Aristotle. You see this, I don't have a picture of him on the left, but he has a statue who thought about reasoning and logic in our heads, you know, and then it moved up over time. And this Mr. McCarthy coined this name artificial intelligence, just to mimic the way we as humans think and work and act. But, you know, technology was in the 60s, 70s, 80s, and I joined IBM in the 80s. The technology was not that far ahead of doing real things. We were talking about neural networks, machine learning, deep learning, all that stuff. And we tried to catch that into very deterministic systems, rules-based systems that were difficult to maintain, difficult to develop. And this came twice to a halt because we didn't have the technology to really do something with it. But now, 30 years later, you see all kinds of developments. It's IBM Watson. It's Google DeepMind that defeats the best Go player. We did it with a chess player. And you see Facebook being able to recognize images. And you see self-driving cars. All in that is neural networks, machine learning, natural language processing. So it has come back. And there are 4 reasons why it has come back. First of all, and I don't have to tell you that, our society is digitized to a large extent. So we have an enormous tsunami of data coming at us, you know, but we should be able to do something with the data. As a mankind, we are producing 2.5 million of terabytes per day. 2.5 million of terabytes per day. It's a huge amount. And you are adding to that. You are on Twitter, you are social media, you're writing papers, and this is why. We have better algorithms. When I started in artificial intelligence, there were some statistical stuff and mathematical stuff. And I told you, I'm a mathematician by training, so that's why I was attracted to this field. But now, it has developed enormously after 30 years. We can do natural language processing, deep learning. We have very good neural network, machine learning systems. Everything is there. And you know, we have very good processors to work with it. Because you need a fast computer. And you were thinking of Tesla, maybe as a car. But there is a processor called NVIDIA Tesla that's very good at AI, you know, and we are deploying this one in our systems just to do the trick. And last and not but least, it's very easy to get access to these programs. You don't have to be a super duper data scientist to appreciate all this technology. There are APIs that are capturing the real technology behind that. And they are in the cloud. You can reach them easily, and I come back to that later. But those are the 4 reasons why it's come back. So we have these 4 factors, but we have the data, but gathering the data is not enough. You need data to train systems, to make it machine learned, but you have to withdraw knowledge and wisdom from that. You need some kind of digital intelligence to do that. And this is exactly why we embarked on this Watson system. You need that. Okay, so this is a little bit of the history of Watson, because we started this as a research project already years ago, a decade ago, you can see it here. And then we started with a demonstration. We calibrated this system to see whether or not it worked. We started with natural language processing, by the way. That was the first field, free text, speech, all things that have been written. Because this is a field we're already working on in 1981. So a long time ago, 30 years or more than 35 years ago. And you know what? We engaged in a quiz called Jeopardy. Who has heard of that? Watson playing Jeopardy? Yes, a lot of people. For those who didn't know that, by the way, Watson is called after this guy. That is the founder of IBM. So it doesn't have to do anything with Sherlock Holmes or Watson and Crick of the DNA. This is the guy, Mr. Watson. Okay? So, and this is the system. A very big system at the time. 2011, it has brought down now to 3 or 4 pizza boxes in a rack, and that's it. It's the software really that matters, you know, and you can cram megabytes, terabytes of data on a disk. You don't need that big system. These were 3 refrigerators next to each other. And we engaged in this quiz called Jeopardy, playing against the best guys ever, Ken and Brett. And you see the guy on the right, Brett, he is a little bit, well, he says he's not too happy. He said, oh, wait a minute, he's on par with me. And then we played, we are in front of those 2 guys, and then we won $1 million. And they were not too happy. But we were not so happy either, because it's a lousy business model, winning 1 million while you're putting 10 million bucks into it, you know. But that was not the point. We just wanted to see if this system really could defeat human beings. And mind you, it was not connected to the internet. It could go through 200 million pages of A4 just in 1 second and glean from that the right answer in this quiz. You know, it was amazing. But then we moved on. So we started a Watson group within IBM as a startup. Can you imagine IBM, a big company, accounting for revenue, profitability, all these KPIs? No, Watson started as a startup within our company. And the only thing they had to do was make yourself known, demonstrate it, work with startups, work with other companies, just to see how it works. And then it matured and became a real business. And then another thing happened. We said our CEO, Ginny Rometty, announced in April 2015 what she called a moonshot. A moonshot, because we are going to change healthcare with all this technology. And we founded a different entity called IBM Watson Health. And it's not IBM Watson Healthcare, no, it's health. It's about us, our total health, not only our clinical information or genetic information, but also our social and behavioral information data. Because all that counts how you will be healthy during your lifetime. And what you need for that is data. So we acquired a couple of 5 or 6 companies, even the weather company, maybe you didn't know that, but that's of IBM. Come on guys, weather and health, that's very important. You know that in this area of the world. And I know that I'm from Amsterdam, and I know that rain and cold it's very, yeah, it's bad for your health. So, but why did we buy these companies? Because they all bring data. We need data to train Watson, because otherwise we are not going to pull it off. So we need data, of course. And then we have a lot of data. So there are numbers there, hundreds of millions of patient records, claims, and also images, because Merge is an imaging company. So we're giving Watson also eyes. He can see at radiology or cardiology or dermatology images. That's all what we're doing with machine learning. Now, this is what we do at Watson Health. This is our mission and vision. So basically, it comes down to doing innovation by taking into account data and cognitive insights. And maybe that's a new word to you, cognitive. because that means that we are scaling our cognitive capabilities. We launched the term, it's from IBM, cognitive computing. And it's not AI, artificial intelligence, it's based on that, but it's more intelligence augmentation or intelligence amplification, because with technology, we can scale our human capabilities, like reasoning, or vision, or hearing, tasting even. You know, all these things are cognitive capabilities. Language, speech, all that. And a cognitive system has the following traits. It understands you. It understands natural language. It reasons about data. So it's like you, like us. We are reasoning about data. It learns, because there's a machine learning system behind that, neural network, but a combination of different technologies. So it improves over time. And this is a big difference with traditional systems of record, where you switch it on and it works. It has a deterministic programming, and it does the same trick all over again. But the machine learning takes some time to bring it up to a certain level. But this is learning, and it can interact with you as a human being, because at the back it mimics a human being, of course, because it's machine learning. We learn, we speak, it does the same thing, okay? And it works on a lot of data, because there is a lot of data, certainly in healthcare. 20% of the data is structured, which means there is a standard around it. It could be the number of days staying in the hospital, your age, your gender, whatever, all numbers in a spreadsheet. Or maybe it's a language standard like SNOMED or LOINC, a classification standard, or DICOM. But the bulk of the data, 80%, is unstructured. That means free text, images, medical photos, all that stuff. Maybe a waveform from a heart department. And IBM Watson can work both on that type of data. Our current computers are made to work on structured. Watson is made to work on unstructured data. And by the way, we don't try to replace a doctor, not at all. We don't try to replace a patient. No, of course not. But a doctor, we are giving him an intelligent assistant so that he can do his work better and more precise and make it more personal for the patient. You know, it's man and machine, not man versus machine. So these systems are adapting to us as a human being rather than we as human being adapting to systems, as we do now most of the time. Okay, so this is a very full sheet that shows the breadth and depth of Watson, because we are not applying this to healthcare only. No, it started there. It started there, and it had a reason. But we are moving Watson forward in all kinds of sectors. We have Internet of Things, of course, and Watson is active in Internet of Things, because, again, it's the interpretation, gleaning wisdom and knowledge from a lot of data that comes from sensors, for instance. Could be healthcare related, of course. So you see, it works on language, speech, vision, all that stuff. It is a platform, and you can work with it, and I'll show you in a minute. Now, how are we bringing this to the market? We have APIs on a platform as a service cloud, and that's perfect for startups, because they have access to a lot of this technology, can use it sometime for free, and can play with it, and bring your own APIs or your own stuff, and leverage open source software. But we have license applications and license in the cloud, like Watson for Oncology, which is a big application we made ourselves, of course, and we're not providing that through a PaaS platform. And these are the types of applications. We have tons of applications now. I won't go into them. It's not important now. But you know, we have this taxonomy of fields where we are active in. So we have a Watson for Oncology that helps doctors to pull up a treatment plan for their patient. And maybe they know it, but sometimes the doctor is alerted that there is something else. There's maybe a clinical trial which his patient is eligible for. You know, and how can you keep abreast of your field? Because these doctors all suffer from a disease called infobesity. Infobesity. They have too much information coming at them. You know, every 40 seconds there is a new summary on PubMed Medline of something that's happening in the healthcare world and life sciences world, and you cannot keep abreast with that. They only have 5 hours per month to read articles in their field. So it's undoable. So how can you be sure that your doctor is giving you the right treatment, of providing you with the right clinical pathway? Well, here is this assistant that can do that. So a lot of these things. So how do we work? We don't work alone. I mean, I am working in IBM Watson Health. To start with, I have more than 200 colleagues that are ex-oncologists, ex-pediatricians, ex-nurses. Why are they working in my company with IBM Watson Health? Because they are inspired by technology, that technology can make a huge difference. Not that it can solve everything, but it can solve something, and something big. And that's why they are working with us. That's for starters. But then, outside IBM, we love to work with startups. We love to have alliances or partners, or of course clients, because we are a commercial company. But you see here, one of the first was Memorial Sloan Kettering. And Memorial Sloan Kettering is a company that's a hospital, a cancer center in New York, that worked with us to develop Watson for Oncology. And they're still doing that. But you see, in Finland, we are working with the government of Finland to make healthcare better there. It's just started, we are improving, okay? And there are a lot of others. This is not an exhaustive list, by the way. So one of the things we do, for instance, with Medtronic, and this is quite astonishing, because, you know, there are people that are suffering from diabetes, type 2, say, and there are tons of apps that can help you with managing your disease. But here, that's only for you with one guideline, maybe with one piece of clinical evidence. What we do here is organizing a cohort, hundreds of patients that are like you, patients like you with the same profile. Medtronic provides us that because they have glucose monitoring, they know about insulin pumps, all that stuff comes out of there, and they're giving to us, IBM Watson Health, and we provide them feedback for a better lifestyle. And we are warning them because this app is capable of predicting a hypoglycemic event 3 hours in advance, where the state of the art is just half an hour. And then you are feeling really bad. So this shows the potential of how you can grab data from a crowd and being able to improve on that and provide people with a better lifestyle. In that this disease shapes up to your life other than the other way around. There are a lot of startups we are working with, by the way. You see here a couple of the early days, GenieMD, WellTalk, I won't go into them. They are for patients, but also for doctors, like at Point of Care for instance, has a fantastic app for multiple sclerosis. But Cognews is here in the panel, is also one that is producing a rehab platform for the continuum of care and is using Watson technology. So it's open to everybody, you know. And this is a site, and you will get the presentation where you can go to if you are interested to work with us, and you'll find tons of information. Let me just show you what you can do. First of all, there is this Bluemix platform. We are calling it Bluemix. It's a platform as a service where you find Watson technology. It's from IBM, where you find open source stuff like Mongo database, Node-RED, all that stuff that you like on GitHub. You can bring your own, and you can work with it. And it's based on the open cloud standards. And these are a couple of the capabilities you see. So if you go to this site, you will see these kinds of services. A lot of services like text-to-speech, speech-to-text, visual recognition, a lot of stuff. And I just want to show you one which is called Personality Insights, because this is an API that's able to glean from just text what kind of person you are. So if you are writing something, it will see through the text and know by psychology theory what kind of person you are. I did this. This is the Personality Insights site. So you see, you can also add your Twitter handle if you are interested who you are or who somebody else is. But you see, you can take a piece of text that's there already from Obama, but you can put in your own text. And what I did, I went to a speech of the president of Estonia, who was here yesterday, you know. And but what she said is on the websites, because Estonia is very open in what they convey. But this is another text, a long text, because that's better to glean her personality, you know. And you can copy and paste this text and put it in the API, and out comes her summary. So you see, you are, what is it? Shrewd, analytical, and particular. So this is the president of Estonia. Okay, and you are philosophical. And at the right side, see, you likely be sensitive to ownership, what is it cost when buying automobiles. All that stuff comes out. And you think it's maybe a game or something. No, it is not. It's based on the big five of psychology. You know, and you can go further and then you see the personality, her needs in life, and also her values. Yeah, and just by the sheer fact that she had this speech. And you can try it yourself, maybe with other pieces, if you like it. You know, and there's this sunburst visualization where you see her, the big five, and I see that, let's see, I cannot read it, but up in the right top there are outlayers, and I think she's open to, yeah, to anything. She's very open, but you see all other things. This is just, yeah, one piece of text, but you can put in your own text or more, or even your Twitter handle to see. Now, mapping this to healthcare, just give you one application how you can deal with that as a startup. We did this in research, and we scrutinized patients that were suffering from psychosis. And you see here that 1 out of every 100 people between 14 and 27 is maybe a high-risk patient for psychosis. Those people go to a psychiatrist, and they discuss, they tell. And all these things are scripted. We put it in the system, just like the API I showed you before with personality insights. And now you can, with 100% correctness, predict when the person in question is going into another period of psychosis. So that means that you can protect him against himself. Just by gleaning his own data, the things, what he is saying, the words, you know, the sentences, the phrases he is using, it can be done. And that's great. It's all by gathering data and machine learning, you can reach this. Okay, if you are interested in food, by the way, because it's running late now, we have a Chef Watson. It's also healthcare, in health. And you can cook with that. There are recipes there. And yeah, you go to the website, ibmchefwatson.com, you see what's all about. It's based on recipes, on food pairing algorithms, and the psychophysics of how we perceive taste. So if you have still broccoli and blue cheese in your refrigerator and you want to know what can I do with that, you can go here, okay? But maybe you are interested in cocktails, then download this and you can appreciate IBM Watson. Okay, let me stop here. I hope this is a swift introduction to what you can do. And this is maybe not too serious, but we are working on a next version of Chef Watson that is for health and healthy lifestyles. So surely we are thinking of that. And with that, I thank you for your attention for the moment. Okay.